right, hi class. So a number of you guys were out sick today or just late. So I wanted to go through and make this video about simplifying radicals. So our I can is our second I can, and it is I can simplify non-perfect square root radicals. Remember, the perfect square root radicals are those things on page 2 and 3 of our notes that we highlighted. All right, so in your notes, you will pick up a new vocabulary sheet to staple to the back of your packet, and these are the words that we cover today. So just a brief recap. The radicand is the number underneath our square root symbol. This is the radicand. Okay. The radical is anything that's telling us to find the root. So we have square root, cube root, to the fourth root. And notice that those are all really small numbers in that little crink of the radical symbol. A cube root simply can be represented as a side of a cube. So if we think of as a cube as being a square, we are going to have each of those sides be that same length, okay? And then the square root is just that same side of each side of the square is the same length. All right, so for more words, we have covered coefficient before. Remember, the coefficient is that number outside of the variable. So if I have 3x, the coefficient is that 3. If I had 4 and 1/2 x, the coefficient is that 4 1/2, because that's what's timesing the x. All right, so the product is just the answer to a multiplication problem. So if I had 3 times 25 equals 75, that 75 is the product. All right. So if I had 75 and I was finding what were factors that went into 75, I would say 3 and 25 are factors. There are other factors, 5 and 15, and 3 times 5 times 5. Those are all factors. And then, of course, variable, the unknown, or the letter that we use. We use y, we use x, there's some z going on, we'll have m's. Pretty much any letter can be used as a variable. However, we stay away from o because it looks like 0. All right. These are the 4 steps to simplifying radicals. So please write down the missing words in your notes, pause the video, and then go on to the first example. All right, so here are our first examples. So I'm looking at example A, and it says the square root of 8. So I go to my prime factorization, and I see that the square root of 8 is 2 times 2 times 2, which, makes sense, right? So now what I do is as I circle the same number. So I have a 2 and a 2. Those are the same number. I can't circle 3 because this is the square root. So remember, the square root has a little 2. That's telling me I need to find pairs, 2 of the same thing inside. So now I'm going to rewrite it with my pairs together, 2 times 2. And then in the other radical, I'm going to take the leftover piece and write it over there. All right, so now I can either use my calculator, or I know that the square root of 2 times 2, or the square root of 4, is just 2. So this guy comes out as 2 in my calculator. Now, I cannot do anything else to this last radical and its radicand, so they just come outside just the way they look. mainly because if I put it into my calculator, I would get a very impressive decimal between 1 and 2. It would be 1.4 something, and it would go on forever. As mathematicians, we like to be as concise as possible. Even our calculators are rounding to that last decimal place. But if I wrote it as 2 square root 2, then I know the exact number. All right, so let's talk about this. We have example B, the square root of 27. The square root of 27, first I go to my prime factorization chart or make a tree, and it tells me that it is 3 times 3 times 3. So now I circle a pair, or 2 of them, and so I rewrite it as 3 times 3, and then my last guy comes out by himself, and it is just underneath that. Okay, now I type in my calculator the square root of 3 times 3. Well, that gets me 3, and then I can't simplify the square root of 3 at all. All right. Example C. Example C says the square root of 75. Well, I go to my prime factorization chart, and I see that it is 3 times 5 times 5. Well, I cannot circle the 3 and the 5 because those are not the same numbers. But I do see that I have 5 times 5. So I'm going to do that one first. 5 times 5. And then what I have left over is the square root of 3. So I type this into my calculator and I come out with 5. And then I write what I have left over. All right, so you might be able to start to see this pattern, that every time that I take a pair, like up here in example A, and I times that pair together, and then I take the square root of that pair, I come out with one of those pairs. So you see that here I have the square root of 2 times 2 equals 2. The square root of 3 times 3 equals 3. The square root of 5 times 5 equals 5. Because these are perfect squares. So I'm trying to find, really it's actually the square root of 25. Well, the square root of 25 is 5. The square root of 9 is 3. The square root of 4 is 2. And so it's really relying on that first little bit we learned about perfect squares. All right, so I'm not going to go over all of this, but I do want to talk about this last guy right here. He has a coefficient, and you can see through the steps of my work that the coefficient stayed outside, okay? And so the coefficient has to stay outside because it's going to get another coefficient when I simplify, because the square root of 8 is 2 square root 2. And then they just times together to get the 8 on the outside. All right, class, I hope you've enjoyed this video, and I'll see you tomorrow. Bye.